Okay, so on the circles below, sketch the indicated angle. Label x and y coordinates of the angle and then convert to radians, give an exact value. There's two circles. You can only see one at a time. So first of all, you can draw your triangle directly inside the circle as provided, or you can make a separate triangle. I'm going to probably do both. So what is minus 2 pi over 3? So remember, if we start here at 0, this is at the point 1 comma 0. But the angle is 0 over here. And then you move around, the whole circle is 2 pi. So that means pi is over here, pi over 2 is over here. But if I'm going backwards, I want 2/3 of pi. So it's going to be somewhere in this quadrant. It's not going to be right here, but that's approximately where it's going to be. So what is it? What is it if it were a positive value? Okay, so 2 pi over 3 as a positive value is 2 pi over 3 times 180 over pi. So you cross those out and you calculate it. You just say 2 times 180 divided by 3, and it tells you is 120 degrees. Okay, so this is radians and these guys are degrees. So that means what you have here is 120 degrees. And that means you have 60 degrees over here. So that's the angle we're looking at. And so we already know, it says give x and y coordinates of the angle. So what I mean is the terminal point. And so you already know that whatever you're going to do, the x and y are both going to be negative because we're in quadrant 3. Okay, now we have to figure out what's actually going on. So let's look at this particular reference triangle. Right, so I'm just going to draw that triangle out. And if that's 60 degrees, I'm going to make it look like there's going to be an equilateral triangle thing going on here, right? So if that's 60, then this guy down here is 30 degrees in here. So actually, no, I just want to draw. It's a bad picture. There we go. That looks more believable. So this would be 30 degrees, this one's 60 degrees. You don't have to draw your triangles to scale. I would just like to do it occasionally so that you don't get completely disoriented here. So if we have a 30, 60, 90 right triangle, it's half of an equilateral triangle. So that means the ratios of the sides, the two sides that are obvious, so half, if you have half of an equilateral triangle, then this guy has to be half of this guy. Alright, that's fine. So now what? We have the hypotenuse and we have a leg, and we want to know what the other leg is, and we just use the Pythagorean theorem, and you say 1 squared plus, quantity squared equals 2 squared. So quantity squared is 4 minus 1, which is 3. The quantity we're looking for is the square root of 3. There we go. Okay, and so what do we have? We have, but this guy is on the unit circle. So that means this is actually divided by 2, divided by 2, divided by 2. So the answer here is minus, let's see, x is going to be minus root 3 over, no, y is minus root 3 over 2, and x is minus 1 over 2. But if you prefer, if you understand how this works, you can just say, okay, well, we can refer to it as sine and cosine. So there's two ways that you can give the answer, right? So this here is equal to 1, right? And then this guy, okay, remember, if you're using SOHCAHTOA, sine is opposite. So this guy is going to be sine of 60 degrees. And then this guy is going to be cosine of 60 degrees. So you can actually, instead of writing 1/2, you can write cosine of 60 degrees. and sine of 60 degrees. If you flip it in the process, if you think about 30 as being your angle, you could call it minus sine of 30 degrees and minus cosine of 30 degrees. All these are correct. These are all fine answers. Okay. Make sure we did what the question asked us to say on the circles below. Sketch the indicated angle. Yep, did that. Label x and y coordinates of the angle, meaning the terminal point of the angle. Yep. Convert radians to degrees. Ah, that's something we didn't quite do. We kind of did it, but not quite right. So what we need to do is figure out what the radians are. So we converted 2 pi over 3, but not negative 2 pi over 3. So we can say negative 2 pi over 3 is equal to negative 120 degrees. Otherwise, we haven't officially answered the question as asked. Okay, there we answered that question, and any one of these answers is perfectly fine. I think this is the one I put on the answer key. But all 3 of those are perfectly fine answers for the second question, and I did label them. Okay, so let's go to the next one and do the same thing again. I'm just going to erase this so it doesn't get in my way. Okay, so it's 150 degrees. So that's positive, that's good. 150 degrees equals, it's going to be pi over 180 radians. And so let's go ahead and figure that out. 150 divided by 180. I don't like that. I have to just reduce this fraction. 15 pi over 18. Let's see. I didn't answer that on the answer key, but you know, that's fine. I mean, that's radians. I don't like the way that looks, but that's what the answer is. Sometimes that happens. I mean, I'm thinking that there's a better way to write that, but I don't think there is. Alright, so what happens? If this is 150 degrees, that means there's 30 degrees left over here. So we can go ahead, and this one is perhaps a little easier than the last question because only one of these guys is negative, right? So the x value is going to be negative and the y value is going to be positive. And then we're just going to use the reference angle of 30 degrees. So let's just do one of the 3 formats that we had up above. And since I don't feel like calculating it, the adjacent angle is 30, and this would be cosine down here and sine over here, right? Referencing 30. So this is just going to be minus, let's see, x is minus cosine of 30 degrees, and the other one is sine of 30 degrees, and that's an acceptable answer. So, okay, so we're done with that. I have to figure out how to stop the recording, so pardon me.